This is Chapter 9.1, Testing Claims. We're looking at a problem that says braking distances in dry surfaces. The weights in pounds of 8 vehicles and the variability of their braking distances in feet when stopping on dry surface are shown in the table. Can you conclude that there is a significant linear correlation between vehicle weight and variability in braking distance on a dry surface? Use alpha equal 0.01. Well, first of all, you have 8 ordered pairs. These numbers are going to go in L1 in the calculator, so you're going to go to Stat, Edit, and then you're going to put these numbers in L1. You're going to put these numbers in L2 because that's your Y variable. And now if you're using technology, you may not want to do all of this that I'm getting ready to show you. But anyway, you can use Table 11 in the Appendix B as shown in Example 6 in the book, or perform a hypothesis test using Table 5 in the Appendix B as shown in Example 7 that's in your book, to make a conclusion about the indicated correlation coefficient. If convenient, it says to use technology to solve this problem. So I never find the correlation coefficient by using that huge formula that's in your book. I always put these numbers in L1 and L2 and go back to Stat, over to Calculate, down to number 4, linear regression, and I find out what R is by doing that. It'll tell me the slope, the y-intercept, and R. So you're going to find out that R is 0.623. There are 8 entries. If you count them here, you have 1, 2, 3, 4, 5, 6, 7, 8. And your significance is 0.01. And if you look up in the back of the book, you look this up on Table 11, 8 at that significance level, you'll find out that your critical value is 0.834. And then you just take R and you say, here's R, it's less than the critical value, so this correlation is not significant. If you work it the other way, you're going to first look on you're going to use Table 5. You're first going to write your claim. This is going to be a two-tailed test because it's equal and not equal to. There's your significance. There's degrees of freedom. You look it up on Table 5 and you'll find out that T is less than that or T is greater than that because the tail goes off on both sides. So if I draw that for you, it's a bell-shaped curve, and this is negative 3.707, and that is positive 3.707. So anyway, that's kind of what you're looking at. And from there, you're going to go down and you're going to find the T value. And now remember, all of this can be done on a calculator, but there's the formula. You fill it in, you find out that T is 1.951, and that's going to occur in this area. So 1 is somewhere in this area because it's lower than 3. So since it's not in the rejection area, you fail to reject the null hypothesis. There is not enough evidence to conclude that there is significant linear correlation between weight and variability in braking distance. The other thing I wanted to show you real quick before my time's out is you can also go here, and this exercise 33 tells you how to test claims. And it is example number 23, which is this one, I think. And I missed it. Hold on a minute. I may run out of time before I can get it back to it. There it is. So I would work through this example, and it kind of shows you how to use the calculator pretty good. So I think you'll be able to go from there and find out how you can do this.